Welcome, my dear students. We are going to study the radius ratio rules. Radius ratio plays an important vital role in determining the structure of ionic crystals or compounds. The structure of ionic crystals are determined by relative sizes of ions, relative number of ions, and radius ratio. The relative sizes of ions will give some idea regarding the ions that form close packing and the ions that occupy voids. Generally, cations are smaller and anions are larger. Therefore, anions form a close packing and cations occupy voids. By knowing the sizes of ions and applying a simple geometry, it is possible to find out the largest number of ions which can be in contact with another ion, that is the coordination number of a smaller ion. Depending on the number of anions around the cation, there are four types of voids: trigonal or triangular void. The coordination number of cation is 3. Tetrahedral void, coordination number of cation is 4. Octahedral voids, coordination number of cation 6. Cubic void, the coordination number of cation is 8. The ratio of radius of positive ion to the radius of negative ion is called radius ratio. Radius ratio is equal to the radius of positive ion upon radius of negative ion, means R plus upon R minus. If radius ratio value is smaller, the radius of ion in a whole become smaller with respect to the radius of lattice ion. The effect of radius ratio on fitting ions in the crystal in a given is below. Radius ratio, occupancy of smaller ions. Radius ratio is greater than 0.732. Occupancy of smaller ions is too large for close packing. Less than 0.732 but greater than 0.414. It is suitable for fitting in octahedral hole. Less than 0.414, then it is suitable for fitting in a tetrahedral hole. The limiting radius ratio for a different coordination number and its significance. Limiting radius ratio is the ratio of radius of a cation to the radius of anion. When there are cation-anion contact and anion-anion contact, by knowing the sizes of ions and coordination number, the radius ratio range for stable structure can be calculated by applying simple geometry. For example, in case of ionic compound AX with the coordination number 3, there are 3 different ways in which X minus ion surround A plus. The structure A, first structure, that is a stable structure of ionic compound with the coordination number 3. Stable structure, quite stable structure, because the positive ion A plus finds 3 negative ions X minus immediately in contact with it. The forces of attraction will be quite strong. The structure second, that is a limiting case of a stable structure with the coordination number 3. The limiting case of stable structure in which negative ions X minus are in contact with A plus ion, but there is also negative ions contact, that is X minus ions are in contact with each other. Therefore, they repel each other and stability decreases But compound is still stable and can exist. If A plus ion becomes still smaller than the X minus, the structure 3 becomes an unstable structure and it is therefore cannot exist. It can be shown by applying simple geometry that radius ratio range of ionic compound with the coordination number 3 is 0.155 to 0.225 for stable structure. Similarly, by applying simple geometry, the appropriate limiting radius ratio of a common coordination number 4, 6 and 8 can be worked out. Sum of the coordination numbers and their limiting radius ratio. Limiting radius ratio, coordination number of a cation A plus and geometry or the crystal structure of B minus and example. If the limiting radius ratio is less than 0.155, then coordination number of cation is 2 and geometry is linear. Then example HF2 minus. The limiting radius ratio of 0.155 to 0.225. The coordination number of cation 3, geometry triangular, example BO3 3 minus. Then limiting radius ratio is 0.225 to 0.414. Then coordination number of cation A plus 4. Then the crystal structure of B, that is the geometry tetrahedral. Then example zinc sulfide type. Zinc sulfide, it has the limiting radius ratio 0.40. Another, that is limiting radius ratio 0.414 to 0.732. The coordination number of cation is 6. The geometry is octahedral. Example sodium chloride. Then the sodium chloride has the limiting radius ratio is 0.524. Then limiting radius ratio 0.732 to 1. The coordination number of cation 8. The geometry is a cubic. Example the cesium chloride, cesium bromide. The examples cesium chloride, it has the limiting radius ratio is 0.884. Then the limiting radius ratio of 0.414 to 0.732. The coordination number of cation is 4. The geometry is a planar. Example ICl4 minus. The limiting radius ratio is 1. Then coordination number of cation is 12. The geometry is a close pack of spheres and example are metals. Thus limiting radius ratio gives an idea of stability and existence of compounds. It also helps in predicting the structure of ionic compound. For example, the sodium chloride, it has close packing, that is a cubic close packed structure. The coordination number 6s/6. Cesium chloride, the body centered cube, coordination number 8s/8. Zinc sulfide, zinc blende is a cubic close packed structure. Then coordination number 4s/4. Zinc sulfide urzites, it is a hexagonal close packing structure. The coordination number 4s/4. Hence there are structure based on the closed packing. Thank you.